Hi everyone, today we're exploring how to write random apps, or rather we're going to write an app that's going to produce a random app by using text generation, which we looked at in a previous couple of weeks. So what you'll need is this library, which is called Grammy, version is 0.1.1. This is something we used last time, so just very briefly, we need a grammar object, which you can obtain by just calling Grammy, and we can flatten it based on some original key, and you can also add certain symbols. So for example, S, which is going to be either A or B. So if we expand S, it's going to expand into either A or B randomly. Right, so using this, we can expand this, I suppose, into something a bit more complex, something that's normally used for defining formally programming languages and stuff like that. So we're going to use a series of expansions which allow us to build a Java syntactically valid application sort of thing. Right, first of all, we need some, we won't even do anything with that yet because we need some code that we're going to write into a file, right? So the plan is to write a file called main.java, for example, into this package, and then using IntelliJ to actually then compile and run the thing. Right, let's call it code list, I guess. This is going to contain the lines of code that we're going to produce. And then all of this is going to be written to paths get, where are we writing this to? So it'll run from top directory, which means it's going to be source main java column lsb algo, which stands for algorithm, then text gen, and then finally main.java. So this is the name of the file, and then the stuff to write is code list, and then it throws an exception, so I'll just do that. Yep, that's cool. Yeah, let's just run this. So I'll produce a main.java file, hopefully. Yep, there it is. We can open it. We're going to split this into the right hand side, and we no longer need the Project Explorer since we can just write into this file on the right directly. Cool. Now, what else? So the beauty of this thing is that this little s could expand into another s. And we can do that to keep expanding this recursively. And if we do that, we can end up with more than just one statement. So we'll use as a statement, right? A statement could be something like that, for example. Hello world will do. Alternatively, let's just print 0, I guess. That'll do, to avoid doing a backspace and all that kind of stuff. Now, if we can run this now, what is it going to give us, do you think? So we'll need to add another symbol, which is the start. So it's called origin, or you can call it something else. And it's going to just have a bunch of these. Going to have expand s, new line, expand s, new line, expand s. Something like this. And then finally we're going to flatten origin, which is going to give us a result, and that result we're going to populate this code list with. But before we do that, you'll note that a Java application needs to have things like package, There's imports, potentially class name, and the entry point. So let's do that. You can do that manually because, you know, it's going to be fixed for all programs that we generate. Let's do that. This is a package. Then I don't think we need any imports at this stage. So we'll just go public class main. And then we need to make sure we complete the curly brace at the very end. Then we'll need the entry point, public static void main, which takes an array of strings. And we also need to close that scope. Let's do indentations as well. So this is top level. This is 1, 2, 3, 4. 1, 2, 3, 4. This closes that one. Let's run this. That should populate our main.jar with some basic stuff. Yep. Now the good news is this on the right hand side already is compilable, is a syntactically valid program that we can run. It won't do much, but at least it's compilable. Now anything in between the main scope is what we're going to add this thing into. So what is it that we're adding? We need to add all, right? Arrays, stream, this, but split with new lines. Because we're going to add a bunch of new lines after each statement. And then we need to indent all of this, right? So it's line followed by actually prefixed with 1, 2, 3, 4, and then further 4 spaces, 1, 2, 3, 4 plus line itself. So we're not actually doing too much. We're just indenting it really. And now let's run this. We will probably end up with a bunch of system.out print line statements. Cool. So you can see that each S as a statement gets expanded into one of these two, because these are the two possible expansions. The first one is just recursively is going to expand it into itself, and eventually it's going to find this branch and settle with it into one of these lines of code. Again, not very meaningful, but then I don't think we should be expecting any meaningful output anyway, since it's a randomly generated application. So what's the goal here? Let's introduce a few variables so that you get to see how to use actions within Grammy. And if we can then perform some actions with these variables, like basic operations like plus, minus, and so on, and then we'll print the result to the terminal in the new randomly generated application. Yeah, and then we'll call it a day. Right, so how do we create variables? Well, it's just like this, right? Yeah, I mean, generally, yes, but the problem with this is if we're going to expand into this branch several times, or at least more than once, that kind of breaks it, because we can't have the same identifier declared twice. So Java compiler will complain and it's not going to compile. To avoid this, what we could do is produce something like var names, I guess. We could put like the entire alphabet in there if we wanted to. I'll just hard code some values to simplify this. A will do B, C. These variable names are not very meaningful, but then again, it is randomly generated, so that's good enough. And then if we wanted more, to just, go something like for each character starting from A all the way to Z. And then you can use uppercase as well. And then populate this thing as necessary. For now, this looks good. We're not going to go very far anyway. And then we can use something like this. And this basically means replace var names with one of these. Now, again, we could run this and it will give us something, but it can still be repeated, right? Because it randomly chooses one of them, but it doesn't mean that it's not going to choose the same thing twice. So how do we solve that problem? We can solve that by having another symbol called used var names. Now it won't let me initialize it to an empty string. So I'll have to do a space, or we can create this at runtime. That's fine. And now what we can do is use an action. So the way actions work is you can access these symbols and then you can modify them at runtime. So we'll use this, used var names. We're going to append something to that, and we're going to remove what we generated from var names. So I wonder if we should get rid of that first and then add it to here. So var names minus what we picked, but we need to store what we picked somewhere, right? So we need another variable here. That variable is going to be called, let's call it var. And we'll need to unpick this because that's getting complicated. Right, so the first action, we are expanding var names, so it'll pick one of these. The one that is picked will be set to var, and we've put an exclamation mark here saying overwrite. So whatever var had, on the first call it won't have anything because it doesn't exist yet. But once it has been created, we're going to overwrite its data by using one of these that we just generated. We're then going to subtract what we generated from var names using var, which is created here. So by the time we reach to this action, var will exist in the context. So it's basically like programming, but slightly different, I guess. It's like using text for programming, which I suppose is what we're doing anyway. We're editing source code, which is text. And then finally, once we've used var, we're going to add it to here with a plus symbol. So we're saying also keep track of used variable names because we're going to access them later or something. And that should allow us to only use unique identifiers. They obviously are going to run out at some point if we use too many statements, which we can try and do because we can have something like this, right? So S, single S could expand into two S symbols. Let's try and run that. It has nothing inside. Now that's alarming. Why not? Var names has to be something. Oh, we're not actually using, if you look here, all these three things are actions. There is no single expansion yet. So once we've done all the actions, once we've stored everything, let's add the variable name in there. It's now trying to compile my newly created file, which it won't compile at the moment. So yeah, we've just run out of rule set for var names is empty. So var names, you can see there's a lot of stuff in there, but once we've run all of this, we've actually run out. So that's not good. We can try to fix it by adding more stuff, more variable names to use. But for purposes of this simple random application, it should be fine. So it's currently just using this. So it's created an int variable, assigned it to 0. Which again, we can, we can make this random if we wanted to. So for now, let's just stick to something like 5. And then it's going to print 0, which is, again, a bit boring, but is fine. Now, here's an interesting thing. We could make it print something like used var names now, because this thing exists in our scope. It's empty by default, but as we create more variables, it's going to populate it with more stuff, with more variable names. So create a D or create an I variable, and we just need to print it. Let's see if the next program will give us that. Because it's randomly generated, every time it picks a different seed, it will result in different actions. Oh, it's use var names, not user. Oh, it's used var names. There's a D there. So yeah, we created a bunch of variables, initialized them with number value 5, and we printed G to the terminal. Now, as a last thing, I suppose, this will run, I mean, it will print 5. But as a last thing, let's make this do something with variables. So let's add another branch here. That is going to be result of time int, so it's going to be called result. And we know it's going to be a type int because no matter what operation you pick between two ints, it's going to result in an int, right? It's plus, minus, multiply, divide, and they all give us ints, so that's good. Add symbol operation of multiply, add, divide, and subtract. So an operation is one of these if we define it that way. That's the interesting bit, because we can define things in a way that we want them to be defined. In which case the result is just one variable name, some operation. I suppose you no longer need spaces here, actually, because we can add spaces here for readability. Another variable name, and it's going to be one of the use variable names. And then what we can do is just print the result. At this point, we can't guarantee that this branch will be called. And again, there is no linearity per se, so we can't guarantee that these variable names will exist by the time we get there. But just right now, it generated something pretty interesting. It created a variable of type int with an identifier called h. It assigned it to a value of 5 because this thing is hard-coded. I think there is a way to not hard-code this. I think there is a pre-built num symbol. I'm not going to use that because we haven't talked about pre-built functions yet. Then it's going to create result, which is that one. It's going to pick one of the used variable names. The only variable name that exists in our scope is h so far, so it basically took h. It picked one of these, multiplied by h, and then new line, print out the result. So this is actually a program for squaring any number that is given. It's not a great program, but you know, it does compile, so it's syntactically correct. And it does run without any issues, so there are no runtime errors. And that is pretty much it. I mean, we can run this a few more times to see how it breaks and how it will run differently, and what kind of things it'll produce. These are going to be very primitive, if any. So for example, we can't guarantee that this won't be the first thing running, which is what it's doing right here. It's the first thing where we don't have any variable names. So every time you run this, you're going to end up with either a valid program that's perfectly fine to run, or some abomination that isn't actually compilable. And obviously we can go to various extents to try and make this even more interesting, seeing what pathways can lead to valid programs and keep those pathways, assign them with a higher sort of output rate or something similar. But generally speaking, I think we have succeeded. We reached our goal in some of our branches of executing our application. Just very briefly, I'm going to recap. We've created our template, which is essentially going to generate a main class and the main method inside it. And then everything else is reasonably trivial, writing to the file. The more interesting bit is over here. We defined some of our symbols, which allowed us to manipulate them in different ways using actions, to create variables using unique variable names, and assign certain values to them, and then perform a basic operation on these two variables that we created. Right, on that note, that is it for this tutorial, or rather just more general video rather than tutorial. We're going to explore the Grammy library a bit more. I'm going to try and formally define what certain things are, because there's only kind of basic formal definition. There are other things that I haven't yet defined, and we'll go from there. Thank you for watching, and if you need any tips on how to use this library, feel free to email me, and we'll go from there. Bye-bye now.